Good morning or good afternoon, everyone, depending on where you are joining us from, and welcome to today's webinar. My name is Eliza Barry from Business Review, and I will be your host for today. It is our pleasure to have Couchbase with us today, who will be presenting today's webinar titled Modernizing the Mainframe, Evolving Your Caching Layer into a Source of Truth and System of Record. Today's guest speaker is Perry Krug, Architect, Office of the CTO. I'd like to welcome you to our platform on 24. You'll notice that this webinar is browser-based, so if you disconnect for any reason, please just click on the link that you received via email to rejoin the session. In order to ask questions, you can send them in via the questions widget. Just type them into the box at the top left-hand corner of your screen and click Submit. We will allocate some time at the end of the session to address any questions or thoughts that you may have. Please use the yellow help widget if you require any assistance, and you can move, resize and maximize any of the windows in front of you to get a better view of the slides. But now, please allow me to welcome Perry.
Thank you very much, Eliza. Good morning and good afternoon. Thank you all for joining us today. My name is Perry Krug. I'm an architect at Couchbase, working in the office of our CTO. And I'm based out of London. It's my pleasure to be coming to you today to talk about how Couchbase and how our customers are using Couchbase as a caching layer and as a source of truth and eventually a system of record. So without further ado, let's dive right in. Take a quick look at the agenda. We will cover very briefly what caching is and means in this modern world. Look at a few of the requirements for moving beyond just simple caching architectures. Spend quite a bit of time looking at some reference architectures for Couchbase, and then some specific customer examples. Okay. Many of you on the line may already be familiar with the idea of caching, using a caching layer, but for those of you that aren't, caching has been around for quite some time, is generally used as a strategy, as an architecture strategy for improving responsiveness, for making things faster. Caches actually apply across all layers of technology, but in this case we're talking about for applications specifically, and generally using storing data in memory to avoid going back to disk or to avoid going back to a slower system. That also means that the more requests, the more responses that you can serve from cache, the less that you have to serve from those slower technologies like databases or disk-based systems, and it means that those systems don't need to be scaled quite as highly. And so the bottom line, you can achieve better performance, better user experience, and again, lower costs by applying or adding a caching layer. Now, caching used to be very simple and lightweight. Just put a caching layer, put another technology alongside your relational database or slower legacy system. Your application was configured to do reads and writes from the caching layer, and any time that the data was not available, go back to the database or slower system and retrieve that. This has been in existence for well over a decade. Memcached, a very popular caching technology, was developed over 15 years ago or so, and has spawned a whole industry of different caching technologies. This is a picture of the way the world used to be. Very simple. Users come into an application, and that application is made faster by a caching layer. It starts to get a little more complicated, though. Now we have multiple data centers where you may want to replicate not only your database but also your caching layer. Your users may be going to an application layer in either of those places and needing to get the best response. So now you're managing data consistency, you're managing high availability, you're managing replication, not only across multiple data centers but across multiple systems. And so we're going to see how Couchbase can be used to greatly simplify this. All of this discussion of caching is really in pursuit of a better user experience. And one of the things that we see now, much more so than 10 or 15 years ago, our customers, our users, the parties that are using our systems are spending much more time interacting with these systems than actually transacting. And I'll give a couple examples of what that looks like. If you imagine 15 or 20 years ago when you wanted to book a flight, you might go into your local travel agent. He or she would provide a couple options, 2 or 3 options of the flight that you could take from New York to London, and you would choose one of those, you would book that. So that was maybe 2 or 3 interactions, a search and a query before you actually booked the flight, and then you walked away and that was done. Fast forward 20 years from then, and I could spend hours searching Expedia and Kayak and Skyscanner, looking at hundreds, if not thousands of different flights. I might even decide that I don't want to book that today and come back and redo the whole search over and over again. This is generating thousands, tens of thousands, hundreds of thousands of requests before I actually book a flight, or maybe I don't even book the flight. This is just one example in the travel industry. This same sort of ratio of interactions to transactions expands through all of our streaming media, browsing and searching, through our retail, shopping experiences, even into financial services, healthcare, and insurance, where we expect to be presented with choices and self-service portals. This is what our users are expecting, and simply put, caching layers are not able to meet that need alone. Our users are expecting their experiences to be feature-rich, to be personalized, to be fast, to be available anywhere and any time. And all this means that we as application builders and architects need to get that data from our systems to our users faster, more richly, and even available offline. So what have we been doing? We started with our relational databases. We started with our transactional systems of record, and we've added caching layers. But then those caching layers weren't enough. And so we added indexing and search engines and replication. We've added all sorts of point solutions around our transactional and analytical databases in an attempt to provide that experience, that performance, that data richness, that capability to our users, and it's made things complicated. Okay, so now let's take a look at how Couchbase fits into this picture. We're going to spend just a few minutes talking about Couchbase. Actually, if I go back one more point, adding all of these point solutions has created a huge amount of sprawl that our operations and application teams need to manage. They are managing the ETL and the replication of data between different systems. They're managing different vendors with different upgrade paths and different integration points. They're managing different APIs and different programming and data models. And all of this makes for a very, very challenging and friction-full environment to operate in, and in some cases isn't even providing the level of experience that our users are demanding. Okay, so let's take a step back and look at where Couchbase fits in this world. If we imagine a series of industries with a variety of customers in there, telecommunications, business services, retail, travel and hospitality, all the way through financial services and media and entertainment. All of these organizations, all of these industries, these verticals are going through their own digital transformation. Some of them have been disrupted already. The media and entertainment industry, Netflix, and now Hulu, and now all of the cable and broadcast providers trying to provide their own streaming media. Travel and hospitality has long been disrupted from the likes of Expedia and Kayak. Each one of these industries at their own stage of digital transformation. And what are they building in order to meet the needs of their customers? They're building systems of engagement. and this comes from a quote. You can see the source online, but the technology adopted by an organization to help facilitate and orchestrate the customer journey via more personalized, seamless interactions across their various touch points. And you can see where we're going with this. All of these industries are building their own systems of engagement. And it means different things to each one of the industries. For financial services, it might be about providing your banking statements and your card transactions faster to you. For telco, it might be about consolidating the billing structure and making it easier for you to view multiple services that you are purchasing from your broadcaster or media or phone provider. In travel and hospitality, might be connecting your journey from the searching of a flight, the booking of that flight, the taking of that flight, the booking into the taking of an Uber to your hotel, the booking into your hotel, and all of the feedback around that. All of these are systems of engagement. They're being built across web, mobile, and IoT applications. Many of you out there are building mobile-first applications. Some of you are building web-based APIs. Some of you are taking and sending data to edge devices over IoT. These are all related because they're all about enhancing the user experience. We can break them down into 4 broad categories. When we talk about Customer 360, everything about bringing the data about your customers together, both to provide them with a consistent experience and for you to have a consistent view across your whole organization. Catalog and inventory focuses on the delivery of new products, the delivery of new content, to be able to quickly and seamlessly publish content and also provide that with fast, flexible, personalized lookups to either stream media, to provide shopping experiences, or to look up financial products. Field service is really about taking that data out to the applications that your employees and your customers are using out in the real world, mostly on mobile phones and tablets, but any sort of embedded system where you need to have that data available. And then finally, the idea of managing IoT, not only taking the data in from a variety of sources, but managing all of those sources and devices as well. And these broad categories of use cases and applications are created through a variety of caches, sources of truth, and systems of record. We're going to focus more on the caching idea, but there is a continuum, a spectrum, from caching, where the application is able to reload the data from its back-end system, a source of truth that aggregates data from multiple systems and provides just that experience to the application, and the system of record as the golden master of data, where you're managing all of the updates and backups and resiliency of the data. And underneath all of this, in any of those various forms, sits the Couchbase data platform. We have customers, as you'll see in a minute, that are using Couchbase for a cache to make their Customer 360 mobile experience better. We have customers that use Couchbase as a source of truth to aggregate multiple product catalogs and inventory and present that over the web. We have customers that use Couchbase as their system of record for their field service applications out to their edge of either their mobile branch, their remote branches, or infrastructure systems. And we have customers that start with Couchbase as a caching layer, and then over time add more and more data and more reliability on it. So let's walk through a couple of these examples. We take a broad picture of the customers and applications that are using Couchbase. As you see, everything from retail and e-commerce all the way through financial services and digital health. And many of these are available online through case studies and blogs and presentations for you to learn more about. So at a very high level, why are these organizations choosing Couchbase? We have a memory-first architecture that allows us to provide performance. So much of caching is about providing high performance, and Couchbase, from its history in Memcached, is able to provide that very, very low latency, high throughput performance. But performance is not enough these days, and just a simple caching layer is not enough. You need to be able to access that data and provide rich services to your applications and to your users. And that's where the idea of a NCL SQL query language comes in. NCL is our name for it, and it's based on SQL, provides much of the same syntax and characteristics that SQL does on top of a JSON hierarchical data structure. We also have full text search that allows you to provide unstructured and fuzzy querying of your data. Replicating the data, as we saw earlier, the need to have your cache or your system of record or your source of truth replicated across two or more data centers and clusters. Couchbase is active, allowing you to read and or write any of those clusters and managing the conflicts and eventual consistency behind the scenes. The idea of scaling out, scaling in, scaling up, scaling down. Couchbase is all about distributed scaling, and we have the ability to isolate workloads within a cluster so that you can really tune the behavior of the cluster for the type of infrastructure and the requirements of the application. Second to last, the mobile synchronization that allows Couchbase to replicate data down to a mobile or edge device and also back up from that mobile or edge device. And then finally, being cloud and container native, especially when you start to look at older legacy databases, Oracle, MySQL, not really designed to be deployed in the cloud or within containers, where Couchbase absolutely is, and we have production support certification for all of the top 3 major public cloud providers, as well as Kubernetes and OpenShift. I'll try not to be too much more salesy, and I promise we'll get to some reference architectures very soon. This is a quick picture of the Couchbase data platform. This is the software, the open source database that we are here talking about, that the one platform, the one technology is used across a variety of applications, across a variety of requirements, from caching through source of truth, through systems of record. And you see there in the middle that core of a memory-first, persistent, scalable JSON document store wrapped in a variety of access patterns. So we have structured query, we have full text search, we have secondary indexing. I'm not going to go through all of these again. We talked about them before. But then all of that is wrapped in a single unified programming model, integrated with a variety of big data tools like Kafka and Spark. We also have ODBC and JDBC drivers for integrating with technologies like Tableau and Informatica and Pentaho. There's security built across the entire stack, from encryption through authentication, authorization, and auditing. And then everything is deployed across on-premise, virtualized, containerized, public cloud, or even managed service environments. One other way of looking at this picture, if you think about a full stack data management, on the far right you have Couchbase Server. That's the database. That's the data center clustered scalable database that then connects to, on the far left, the Couchbase Lite embedded database. It's designed to run on iOS, Android, Windows, and Java-based systems. Connecting those two together is the sync gateway that provides all of the termination for those embedded systems, those embedded devices, and also provides the security and data routing layer to manage which data goes down to each device and which device is allowed to write data back into the centralized and aggregated data store that is Couchbase Server. Talk a little bit about how Couchbase was developed over the years. There's been a constant focus on clustering and the idea of auto-sharding. We've used JSON as our native data model, providing very, very flexible, schemaless modeling, so you can combine data from different sources. You can evolve that data model over time. Everything is done on a memory-first, network-centric architecture that is asynchronous within the cluster and processes to allow for very flexible and scalable and performant processing, and then every workload, every capability can be scaled independently depending on the requirements of the application and the availability of the infrastructure. Couchbase started many years ago as a managed caching layer and progressed through the layers, adding persistence for a key value store, adding JSON support for a document database, adding mobile synchronization, that Nichols query language, full text search. Eventing is a new service that is all about providing triggers and notifications out of the database, and then most recently our real-time operational analytics that allows you to run analytic workloads with much heavier query processing on top of the same data as you're running your operational workload without sacrificing the performance or the availability. Let's talk a little bit about Couchbase and its JSON schema before we get into our reference architectures. I promise you we are getting there eventually. At Couchbase, we talk about storing data in a variety of ways. Many NoSQL technologies in general talk about the denormalization of data. And if you look at the picture below, that's exactly what we're talking about. Taking multiple tables from a relational database model, this is a very normalized model, and aggregating those into a single document because all the data is related to each other. As a user profile document, you want to include not only their first and last name, but any information about that user. So in this case, their skills and experience might be their company information. But denormalization is not always the best approach, and sometimes you want to be able to normalize data for reducing duplication, preserving consistency and integrity of the data. And so Couchbase allows you to have references between the documents, and our query language allows you to join those documents back together, which allows you to trade off denormalization and normalization. JSON allows you to add or remove new values as needed, or even to have multiple documents side by side that have different structures and different fields in them. And we also support storing binary data. Anything that is not JSON can be stored in Couchbase as a blob. On top of that, then we provide data access in a handful of different ways. We have our primary key value lookup. We have our SQL SQL querying, which is our Nickel query language. There is full text search, and then we have our analytics layer, which is built on an MPP architecture for large-scale aggregations and ad hoc unindexed access. All of these access patterns are on top of the same data that you're storing, so there's no need to ETL the data out of Couchbase into another system. There's no need to develop and manage different data models or different programming paradigms. Okay, as we talk about scale and availability, Couchbase, everything that we do is clustering, so whether it's one node or 100 nodes, Couchbase is always a clustered, sharded, replicated system, and the application itself is abstracted from the topology of the cluster. So your application only accesses a Couchbase cluster. It does not need to know how many nodes there are. It does not need to know how many times the data has been replicated. It does not need to know whether you are adding or removing nodes, or whether a node is failing or being recovered out of the cluster. This also allows any application to be deployed across clusters of different topologies. So you might have your application being tested on your laptop with just a single node. There's no configuration, there's no architectural change, there's no behavioral change when you point that application at a 3-node cluster running in your development environment, or a 20-node or 50-node cluster running in your cloud for production. And then lastly, Couchbase allows you to, as I mentioned, replicate data across data centers. We take the approach differently than other technologies to replicate data between individual clusters. So here you see 3 clusters, one in the US, one in Europe, one in Asia. You can have any number of clusters in a ring topology such as this, or in any other topology such as a one-to-many or many-to-one or a chain. And each cluster is completely independent from the other. So it can be of different node counts, it can be of different software versions, it can be of different hardware types, it can even be different clouds. You might have your US cluster running in Amazon. You might have your European cluster running in Google Cloud. You might have your Asian cluster running on-premise even. And Couchbase allows you to replicate data bidirectionally between all of these. Okay, so that's enough of an overview of Couchbase. Let's get into some of the meat of reference architectures and see how Couchbase can be used as a caching layer and more. While I'm here, I'll pause for a moment. Please feel free to submit any questions through the Q&A interface, and we will be able to answer them at the end. Okay, let's take a quick look at a very simple, high-level reference architecture with Couchbase. This is the idea of creating a Customer 360 platform. You can see on the left, bringing data in from a variety of systems. So you might have a CRM, you might have a mainframe, you might have your data warehouse or online store. These are not just databases, these are also systems and sources. But the idea is that, or the need is that all of these are in different silos and you want to create a single unified service for your internal and external view of each individual customer. By bringing that into Couchbase, either directly writing it into Couchbase or using something like Kafka or Spark to stream and pull the data, you can then store data from multiple different systems, multiple different sources, all together within a single layer and provide a set of services on top of that. In this case, we're using a microservices architecture where the application might be order history, notes, management system, profile and preferences, and the login and authentication. And on top of that, exposing it to a variety of different applications. Internally, you might want to look at those customers for your call center and client services department. For your external customers, you might want to expose that through an in-store kiosk, through a loyalty program, or through their own self-service portal. Some of that you might even want to replicate down to a mobile device to provide offline access, or simply have a web-based service for browsers. So this is the big picture. How do you get to this point is not necessarily just something that you drop in and you immediately have a Customer 360. So how have some of our customers walked the path to get to this high-level picture? One simple place is to start with caching, as we mentioned before. You might have one or more systems of relational databases and mainframes that you want to provide access to, but they're simply not fast enough. They're not scalable enough, or they're not flexible enough to provide applications and services on top of. So start with Couchbase just as a caching layer. Your application can still be accessing that relational database and that mainframe, but now gets a faster experience from Couchbase. Couchbase provides, just like Memcached did, provides time to live and expiration, so that data will automatically be cleaned up out of Couchbase and leaves that relational database still as your system of record. As the application gains more and more experience, you can put more and more data into Couchbase, create more and more flexible services on top of it, and eventually start to identify data that no longer needs to live in that back-end system. Okay, so you now have started with Couchbase as a caching layer. You've just switched over your application to get better performance, but now you want to start bringing more data into the system. You would then maybe decide, actually in this case, I want to load Couchbase with from Kafka or Spark, from other applications, from other data stores, and I need to take the data that's being written into Couchbase and send it back off through those layers. Now, this is really creating more of a source of truth. And so Couchbase, in this picture, is serving one or more applications directly, but the data is being fed by other applications or by other databases, and is going out back into to be synchronized with either your Hadoop or data warehouse downstream, or other applications that are feeding from Kafka. In this case, you might even choose that you want to replicate Couchbase and have it geographically replicated around the world to provide a higher level of availability, disaster recovery, or even geolocality, so that your users in one region of the world have faster access to the data that your other users in another part of the world are also accessing. And then putting the full picture together, now we want to replicate that data down to our mobile devices. And here's another picture of integrating data into Couchbase. So you're pulling it from Hadoop or other backing databases into Sync Gateway and into Couchbase, and then replicating that down to the mobile devices and providing a web application view on top of it. This also shows you the ability, as data flows back into Couchbase, as your mobile apps are making changes to data, or those web applications are making changes to data, that can also be synchronized out of Sync Gateway back to those back-end databases. So you have a number of choices of how you might decide to integrate Couchbase into your application stack. If you know you need to be replicating data down to a mobile device, this allows you a very easy way to push data into a Couchbase mobile stack and also receive data out of it to synchronize with those back-end databases. This follows a very similar pattern if you're familiar with CQRS. Okay, let's take another slightly different look at deploying Couchbase and how it might fit as a caching layer and beyond. The idea of microservices, hopefully something that a few of you on the line are already familiar with. The idea of breaking up a monolithic application into one or more smaller services that each have their own back-end database, or maybe even are sharing similar databases, but allow you to develop each one independently from the other. Couchbase in particular, we've just launched our GA version of our autonomous operator for Kubernetes and OpenShift. And what this allows you to do is deploy Couchbase in an immutable infrastructure as code environment on top of Kubernetes, OpenShift, and a variety of the other Kubernetes services and flavors in public clouds, and gives you automatic provisioning, self-healing, geographic distribution, a centralized and templatized management, and automatic scaling both out and back in again, all within the Kubernetes environment. If we take a quick look at what the architecture of this might look like, Couchbase, the Couchbase operator is responsible for deploying and managing those clusters, and as a site reliability, as an SRE, a site reliability engineer, or programmatically can configure and provide that configuration to the operator, which then goes and executes it on a cluster. So one of these configurations might be to deploy a 4-node cluster. You might augment that configuration to say, I want to make that 4-node cluster a 5-node cluster. You might then say, I want to upgrade that cluster from version 5 to 5.5 or on to version 6 or whatnot. And then you might use that same thing to deploy a CI/CD pipeline where you're configuring and deploying multiple clusters and tearing them down after you've done your integration test. All of that is very possible and very flexible with Kubernetes. This is a standardized way now of deploying and managing Couchbase in containers, and is production certified for the open source Kubernetes and the OpenShift variant from Red Hat. Okay, with about 10 minutes left, I'm going to go through a few of the customer examples that are using Couchbase both for caching and more. If we take a look at LinkedIn, LinkedIn has been a long-time user of Couchbase. I'm not going to read all of the text on this slide, but these slides will be available for you afterwards. One of the things that LinkedIn did was they chose Couchbase as a replacement for all of their Memcached as a standard distributed caching layer across the entire platform, and they've gone so far as to make it their standard caching platform. And you can see a blog there that they have written about how they are using and have deployed Couchbase at LinkedIn. Another customer of ours, Experian, one of the credit reporting, credit monitoring organizations needing to provide very high performance write throughput into the system as they gather data from all the different sources. Very spiky traffic where they have seasonal and concentrated access and spikes to their system, but also wanted to help bring on new services. And so starting off with Couchbase as a caching layer, but then being able to leverage the structured query and full text search to provide new and go-to-market services on top of that same data. Experian had focused first on using Couchbase to offload their mainframe, simply to provide a performance boost and a cost reduction by not having to scale out that mainframe or scale up that mainframe as they had to handle more and more traffic, more activity. We'll go through a few more customers. eBay, I'm sure you all know and love out there, one of the world's, or the world's largest online marketplaces. They've been using Couchbase for many years, initially again as a Memcached replacement, focusing simply on performance, but then being able to add cross data center replication, to be able to add centralized and aggregation of data, and also to buffer their writes to their backend systems to provide a more seamless experience for session and cookie and logging events. A quick look at the architecture of one of eBay's Couchbase deployments, or two of eBay's Couchbase deployments, showing both a cross data center replication across 3 different clusters, and also the fact that they do have other database storage systems of record that are in the back end serving the Couchbase as a caching layer. Another good example as we start to wrap up the presentation today, Amadeus, one of our largest customers, the leading provider of IT solutions to the global tourism and travel industry. Some of these numbers might be a little out of date. They've presented many more times about their usage of Couchbase. Initially, we're using a Memcached layer on top of a MySQL layer. It had a number of challenges around scaling, managing consistency between those layers, dealing with the recovery from when Memcached failed. And so over the last number of years have replaced that layer with Couchbase and Consolidated both their Memcached layer and MySQL. So they reduced their hardware footprint, they improved their performance, their simplicity of management, and the ability to scale out and recover from failures without having the sort of cold cache challenges that Memcached created for them. One of Couchbase's largest customers, regularly peaking over 2.6 million reads per second, regularly over 1 million writes per second. Not only is Couchbase fast for them, but it is predictably fast. We have a very narrow band of latency that they're really able to rely upon, and for us to manage the memory, manage large volumes of memory without slowing down, without having some of the challenges that other technologies do. This was Couchbase as a caching layer for Amadeus, and then over the years they have evolved that to add newer services, not only on top of the same data, but also as different applications. One of the roadmap presentations they had a few times in the last of our conferences. This was last year in Europe, talking about first starting with Couchbase as a caching layer there on the far left in 2013, and then starting to add new use cases for their hotel shopping and booking, for their airline availability engines, starting to move over to Red Hat and OpenShift, and managing hotel and airline reservations and security. And so some of these are caching layers on top of existing systems. Some of these are using Couchbase to aggregate data from a variety of other backend stores and provide a system of truth. And some of these are actually using Couchbase as the system of record. Okay, I think my time with you is up. I hope this was a useful set of information. If you'd like to learn more, there is couchbase.com/caching that takes a look at how to start with Couchbase as a caching layer, some of the comparisons to other technologies like Redis and Gemfire. I would highly recommend going through our free online training. It is self-paced and chunked in small hourly modules that allow you to learn about Couchbase both from an architecture, from an operations, and from a development perspective. If you're looking to download, couchbase.com/downloads, and always feel free to reach out to us, info@couchbase.com, or our various forums and Twitter handles. I thank you all very much for giving me the opportunity to speak with you. Again, my name is Perry Krug, and I am an architect in the office of our CTO. I think we have about 10 or 15 minutes remaining. I'll start answering some of the questions that have come in online. If you do have any more questions, please feel free to put them into the Q&A tool within the webinar, and I will answer them as they come in. Seems like we already have a few. Please don't hesitate to send more. One of the questions came in, how does Couchbase compare to Cosmos DB? Great question. Cosmos DB is a cloud-based database, a hosted database from Microsoft, available in Azure. There are quite a few similarities when we start talking about flexible and scalable data access. But as you start to dive in, you'll start to notice that while Cosmos is very easy to get up and running with, it's nice that someone else is managing the data for you. You have to realize that someone else is managing the database for you. And if you have to deal with spiky performance, where you have applications that have a wide range of access requirements, throughput, low latency, it's generally not able to meet those performance and scalability, performance at scalability needs. You also run into challenges with managing the placement of data and the consistency of performance. So you run into hotspot challenges as well as differences in how you can replicate that geographically. Couchbase, on the other hand, is not a hosted database. We provide you with a packaged piece of software or from the open source that you deploy, and you can manage it across any environment that you want. One of the big differences, Cosmos DB is not going to allow you to replicate to Amazon's web services. Cosmos DB is not going to allow you to replicate data to your own on-premise system. If you want to test with Cosmos, if you want to deploy Cosmos in a variety of, if you want to deploy your application on a variety of different clouds, you can't use Cosmos DB, and you can use Couchbase. And so it's a question of what does your application and your architecture require, and choosing the best tool for the job. I hope that helped to answer your question. Another question coming in, does Couchbase's caching layer perform better than InfiniSpan or Hazelcast? Performance is always a bit subjective. You know, there are lots of different variables in terms of hardware and access patterns and data sizes in general, but I would say very confidently Couchbase is one of, if not the fastest caching layers available. Our history comes from Memcached, if you're familiar with that, as a caching layer, caching technology, a very simple, very fast key value store that we use internally to make sure that we can provide the same performance both at a low level of throughput all the way through many millions of operations per second. I know that technologies like Hazelcast and Gemfire are also reasonable caching technologies, though you run into a lot of challenges in terms of Java garbage collection, being able to handle large memory footprints, where Couchbase does not have those problems, and Couchbase has a number of very public customers that are receiving sub-millisecond, even sub-half millisecond response times throughout the hundreds of thousands or millions of operations per second. And we provide a very, very flexible JSON schema or plain key value access, as well as that sort of flexible data access if you want structured querying, if you want full text search, if you want to join between documents. Couchbase allows you to do all that. So it extends much more beyond just a caching layer than InfiniSpan or Hazelcast or Gemfire does. Again, I hope that answers your question. Great, keep sending your questions in. I enjoy this and I'm happy to continue answering. I appreciate your flattery. Couchbase has so many excellent features. I definitely agree. Thank you for writing that. The question though, where do you guys see it going in the future? Where do you see room for improvement or for new features? Whew, that's a loaded question. So I think as our history has told us, Couchbase has been around for about 9 years now, starting off very, very simply. We focused on scalability and performance, availability, and we've added more and more development and integration and capabilities on top of that base, on top of that architecture. That will continue to be our model. And the way that we have decided what features to build, what capabilities to add, is by understanding the market and what our customers and users are doing with the data. If you go back many years ago, Couchbase as a simple key value store, our customers were taking the data out of Couchbase and they were storing it in technologies like Elasticsearch or Solr or Lucene. And so that was one of the first times that we realized, hey, if we had our own full text capability, our users wouldn't need to move the data out of Couchbase. Couchbase doesn't need to be a search engine. It doesn't need to be directly competing with Elasticsearch. But if you're storing that data in Couchbase and you're taking the data out in order to do something else with it, we believe you should be able to do that right within Couchbase. And so that's where our full text search came from. That's where our nickel query language came from. That's even where our analytics service came from. We had customers that were taking the data they were using for their application out of Couchbase and moving it into data warehouses and other databases for performing analytics, and then taking that and moving it back into Couchbase. And so our philosophy has always been to help our customers and our organizations collapse the different layers. And so that's from the idea of collapsing a caching layer on top of a persistence layer, collapsing in the ability to do full text search, collapsing the ability to do structured SQL querying, collapsing the ability to do operational and analytics queries on the same platform. So that's the general kind of philosophy that we have towards the product. In terms of kind of specific areas for improvement, we have a long roadmap, both of our own wants and desires, and also informed from our customers and the market. Focusing in the near term very heavily on multi-document mutations. I won't use the TX word since it has so many other connotations, but providing multi-document operations and mutations, and also focusing on our density of data storage. So right now, Couchbase is extremely fast when a lot of that data is in memory, and we want to be able to provide better performance, better vertical scalability when our customers are looking to store not only 1 or 2 terabytes per node in a cluster, but really towards 10 or even 100 terabytes of data per node. So I hope that gives you some idea without actually committing to any new features, but I'm happy to have a more direct conversation about what it is you need or would like to see from Couchbase in the future. Okay, questions keep rolling in. A good question, is there a proper way to use Couchbase as a queue application? This is a good question. It's a bit of a fuzzy area depending on what you are trying to do with with queuing, with queues. With Couchbase, we do provide a push and pop semantic on top of an array within a JSON document, and so that can be used as a queuing layer. We provide atomic inserts and sequencing through counters so that you can manage a list or a queue. We also integrate very closely with Kafka to allow you to stream data into or out of Couchbase. And in the not too distant future, we are adding on top of our triggers functionality, we're adding feeds and notifications that will allow you to subscribe to a set of changes coming out of Couchbase. And so to answer your question, the idea of a queue can mean many different things to different people. I would say in a very specific setting, Couchbase is not the best technology as a queue itself, but if you need to have queuing semantics and you need to integrate Couchbase within your broader application, then there are certainly ways of achieving that and examples of our customers doing so. Okay, 10 more minutes or so. Start to answer these questions. Keep rolling in. Please continue to answer them. One question: how do you manage data consistency when using Couchbase as a caching layer? This is a great question, and I'll go back to one of the pictures that we had online or on the web. Sorry, in the slides. But here we have data being served both by Couchbase and by your relational database or mainframe. And how are you managing the consistency of data? There's generally two approaches. One is for the application to write both into Couchbase and into the relational database or the backend system. This is a simple approach, but doesn't always solve all of the challenges. The other approach is to use Couchbase's time to live or expiration capability, so that as you make changes, as you write data into Couchbase, after 1 second, after 5 seconds, after 15 seconds, whatever the amount of time might be, that data will be deleted from Couchbase. And then when the application comes along and requests that again, it will see that the data is no longer available. It will fetch it from the database, put it into Couchbase, and then for the next 15 seconds, all of the access to that same data will be served from Couchbase without having to worry about whether it is strongly consistent with the backend system. And so that's a very common pattern for caching, not just with Couchbase, but stemming from Memcached as well, and we support and have customers using that as well. Another question, how do I move data from a relational database or mainframe into Couchbase? I'll go to one of our next slides to answer this. There's always a question about, are you actually moving the data, which means you are taking it out of and putting it out of an old system and putting it into Couchbase, or do you want to copy it? Do you want to keep it in sync? And so you have a variety of different choices depending on if you plan to deprecate or turn off that other backend system. But typically we talk about either the application writing directly into Couchbase or in today's modern world, more likely using something like Kafka or Spark to receive changes from those databases, those mainframes, and put those changes back into Couchbase, and that allows you to maintain a copy, but also over time to decide that you want to deprecate those older systems. Okay, a few more questions and a few more minutes to go. So again, thank you for those of you who are still on the line. If you have other questions, please don't hesitate to send them through the system. Here's another question. Does Couchbase support Spring data? Yes. The short answer is yes. I'll turn it into a much longer answer. Couchbase does have support for Spring data, Spring Boot, and for Java-based applications. We also support Link for .NET applications, as well as a direct .NET API, as well as SDKs and APIs across a variety of other languages, everything from Node.js and Go and PHP, Python, Ruby, Perl, C, C++, C#, the list goes on and on. And then when you are deploying an application out on a mobile device and you are embedding Couchbase out there, we have direct or native APIs for iOS, Android, Windows, and Java, and then also integrations with things like Ionic, Xamarin, and Cordova. Okay, a few more minutes and a few more questions. Why should I choose Couchbase instead of Redis, another popular caching technology? Redis actually came out of Memcached around the same time that Couchbase did, with slightly different trajectories. Redis really started down the line as a data structure server without providing clustering or manageability features, where Couchbase took the simple key value data model of Memcached and wrapped it in persistence and replication, horizontal scalability, geographic replication. And so we're starting to see those two converge again, where Couchbase provides a number of data structures such as lists and sets and hashes, and Redis now has started to provide clustering and geographic replication. I would say generally Couchbase is a more general purpose, a more flexible database technology. Redis is particularly good just as a caching layer, and so if you are interested in managing 3 or 4 different database technologies where you have Redis over here, and maybe you have Mongo over there, and maybe you have Oracle and MySQL, then choosing each individual system might be a choice for you. But if you're looking to choose one technology that can meet 80% of your needs, your data is already in JSON, and you want to put it somewhere where you can provide not only high throughput access, but structured query and full text search capabilities to it, then Couchbase is a much more general purpose storage layer for you that allows you to grow and evolve as your application needs change. Another question back from the related to the queuing question: does the subdocument feature will the subdocument feature be improved in order to manage more array functions? We do already provide a wide list of functionality within our subdocument API, subdocument feature. For everybody else on the line, subdocument is the idea of accessing one or more fields, manipulating one or more fields within a JSON document. So you can either send and receive the entire document and manipulate it on the application side, or you can send a simple command directly to Couchbase that says, just give me this one field, or just write, or just add this one field. And so the question was around managing more array functions. Off the top of my head, I may not be able to list them all, but if you search for Couchbase subdocument on the web, you should receive you should see our documentation, but for array functions, there is push and pop. There is, I believe, intersect scans. There are count and length scans. There are, I think there are remove, delete element. There's a whole range of functions for arrays, and then also for counters, for treating a field as an atomic counter within a document, for managing multiple paths or multiple fields within a subdocument. I'm probably missing a few off the top of my head, but we have, I think, pretty good documentation. But in the event that you don't find what you need or think that you would benefit from some other specific array or other functionality, please don't hesitate to reach out either on the forums or via email to us directly. Okay, I think we're just about done. I will hand it back to Eliza to wrap up. And again, I thank you all for staying with me, for engaging, and for the questions that you had. Thank you again.
Thank you so much, Perry. So that just leaves me to thank Perry for what was a great presentation, and to Couchbase for sponsoring this session. To the attendees, You will receive an email shortly telling you how you can access the on-demand version of this webinar, or you can access this through our website, which is www.business-review-webinars.com. We look forward to sharing further webinars with you, so please do keep an eye out on our website and follow us on Twitter at BRWebinars for daily updates and join our LinkedIn group, Business Review Webinars. Thank you once again, and I hope you all have a lovely day.